Unexpected activity in dead bacteria detected by scientists. Using a stored supply of charged particles for energy, rather than their usual fuel, the bacteria could actively respond to tiny changes in nutrient levels to determine a prime time to wake. The discovery challenges our understanding of not just how disease spreads, but also how life could survive in extreme states here on Earth and beyond. This work changes the way we think about spores, which were considered to be inert objects, says molecular biologist and lead researcher Ghural Soul from the University of California, San Diego. We show that cells in a deeply dormant state have the ability to process information. We discovered that spores can release their stored electrochemical potential energy to perform a computation about their environment without the need for metabolic activity. The implications also spread beyond disease management here on Earth. It's often thought that one way we may encounter extraterrestrial life is in similar dormant states. If scientists find life on Mars or Venus, it is likely to be in a dormant state, and we now know that a life form that appears to be completely inert may still be capable of thinking about its next steps, says Sewell. Bacteria are generally pretty tough, but one of their key survival tactics is being able to shut down into spores, where they can remain in a dehydrated, dormant state surrounded by a protective coating for hundreds of years, surviving extreme heat, pressure, and even outer space. This isn't just a deep sleep, either. Essentially, the bacteria are physiologically dead, with no metabolism. But somehow they know when conditions are right to wake up again. Spores are how diseases such as anthrax, caused by the Bacillus anthracis bacteria, can survive long periods without water or nutrients in the male. Within moments of exposure to suitable conditions, they're able to rehydrate and restart their metabolism, allowing them to become infectious again. But how exactly do spores know when to wake up? Responding to every drop of moisture or whiff of nutrient could mean a lot of wasted energy if the good times don't continue for long. Waiting for a feast might also mean lost opportunities, though. To tease this out further, Sewell and his team tested thousands of dormant Bacillus subtilis spores. The bacteria are considered non-harmful to humans and also happen to hold the record for the longest time surviving in space. Using a mathematical model to explain what was happening, the team showed that each signal triggered the release of potassium ions, and over time the potassium ions became strong enough that it kickstarted the reawakening of the bacteria. They called this a integrate and fire activation model.